first thing I want you to do today, if you don't have a calculator, grab one or pick one up in the front or take yours out. I want you to put in, we're going to be looking at classifying numbers as irrational by their decimal or rational, and converting repeating decimals and rational. So the first thing I want you to do is, if you don't have a calculator, grab one. And I want you to take 0, and I want you to write this in your notes, 0 divided by 5. It does look like this, you agree, right? 0 goes first, divided by 5. What do you get? 0 divided by 5? 0. Try 0 divided by -8. On your calculator, type it in. 0 divided by 8, make it negative. Equal. 0. Did it get 0?
Yeah.
Okay. Yep. Put 0 divided by 523. 0. Any time, because what you're saying is, what do I take times 5 to get 0? And the answer is always 0. But now, I want you to put in 5, and I want you to divide it by 0. Put the 5 first. 5 divided by 0. This comes up in our lesson today. It came out as a division by 0 error. Division by 0 error, or it just says error, right? It is an error. But we can't say that. We have a special name for that. We call it so please write this, undefined. You can always divide 0 by a number. You can never divide by 0. This is really important. It comes up in our definition today. If you put in 20 divided by 0, because this is what you're trying to think. You're trying to say, what do I take times 0 to equal 5? And is there anything you can take times 0 and get it to equal 5? No, that's why we call it undefined. Okay? So we're going to be classifying numbers. When we do that, I would like you to put this word down, real. This is the most general numbers we have, are real numbers. We're going to work with this all year in 8th grade. Next year in algebra, you work with it also. Real numbers. It's every number on our number line. We are not going to spend a lot of time today with the irrational, but I still want you to write that down. We're going to have rational. Below this, we are going to put the word integer. You need to leave some room here to write, okay? Then we're going to put integer. And then our most specific one that we're going to deal with today is called our whole numbers. So when you're filling yours in, yours is going to kind of look like this, and I just need you to leave space to write some numbers behind integers or below them. When I talk about whole numbers, that's like 0, 1, 2, 3, ... meaning 142, 1,738,000. Did you write this down? Write the numbers too, okay? Now we're going to go to our integers. Last year you guys did a lot of integer operations. That's when you worked with 0, you worked with 1, but then you worked with the opposites, -1, right? You did a lot of multiplying with positive and negative integers. No fractions in either one of these categories, right? We have 2, -2. We have 3, -3, right? No fractions in either one of those, okay? When we get to rational, the key definition of what a rational number is, the key definition that you want to be thinking about is rational, is that we can write it as a fraction. Rational fraction. Now by fraction, I also mean it could be a mixed number, okay? Now, when we think of that, this is also a decimal, and this is where we're going to be concentrating today. It's a decimal that ends, sometimes we call it a terminating decimal, or a decimal that repeats. And what we're going to be working on today is we're going to be looking at these two types of decimals, and we're going to write them as a fraction, okay? On Friday, we're going to talk about this last category, which is my irrational numbers. My irrational numbers, when I think of those are decimals that cannot be written as a repeating, so decimals that do not repeat, so I'll put that in front, not repeat, and they never end. Never repeat, never end. Okay? Decimals that do not repeat, never end. An example might be square root. Yesterday we did 2. One of the ones that people think the most often is pi. And we're not going to concentrate on those. We're going to be working with our ones that end and repeat, and in your homework tonight, that's what you're going to be working with. But you will have to classify for our test. So, rational number. What did we say the word I want you to think about for rational is that we can write it as a fraction. So this word quotient, that really means fraction, right? We want to write it as a fraction. And in that definition it says, where we have a quotient, A and B are integers, which means they can't be a decimal, right? You cannot have a decimal as part of your fraction. B cannot be 0. We just talked about that. You can never divide by 0. It's undefined. The diagram below shows how rational, integers, and whole numbers are related. This means every whole number, 0, 1, 2, 3, they are rational. But it's more specific than that, right? No fractions or decimals. Every integer is also a whole number. So -3, just negative without the positive ones. Those are just my integers, but this includes the most specific. So in your homework, I'm going to ask you to tell me, or in this example coming up, is it a whole number? Is it an integer? Is it a repeating? Okay. Rational includes integers. It includes whole numbers, but it's also going to have a mixed number like -5.35, -8.73. It is also going to have something like 0.3 repeating. It's also going to have something like 6.24 where just the 4 repeats. Those are all considered to be rational because they repeat or end. And what you are doing, and I know you've done some of this before, when we write any rational number as a decimal, we can divide the numerator by the denominator. So 3 divided by 5, if we are looking at that. We divide and end up with a remainder of 0. We call it a terminating decimal. Repeating decimal is one where we have either that line over it or we actually show that. So, you are going to be asked to classify. Here's how I want you to classify. Whole number, 0, 1, 2, 3. You're going to put a W below the ones that are whole numbers. More specific would be an integer, right? Integer is more specific, right? So every whole number is an integer, but every integer is not a whole number. Then you're going to tell me your terminating decimals. You're going to put a T. That means it ends, right? So if any of these decimals that end, you're going to put a T below it. R is for my repeaters, and F is for fraction. So the easiest one might be to go through and do your fractions first, right? So if I was looking at doing my fractions first, Andy, you want to tell me where I should put an F?
7/9.
7/9. Any place else?
1/2 and -4.
Those are my 3 fractions, right? So I have F's. I might now want to go with whole numbers. Whole numbers can't be a fraction or decimal, right? And they can't be negative. So if I was looking at those, Zach, what might I be looking at? 8. Any other ones?
-7.
-7 is -7 whole. It's a what? It's an integer. Okay? So I want you to do the rest of them. We did a couple. I want you to do the rest. Then we're going to, Riley, I did 0.25, 0.6. Can you tell me, do we have any other T's that I should put up there? 14.1 is going to be a T.
4.5.
4.5 is going to be a T. Do we have any other T's? Does this end? Or is there dots back there? It ends. That's a T. Someone said, well, that's kind of tricky because it doesn't. Yes, it ends. There's no dots behind it telling us to keep going. Whereas this, if I would write it out, right, this is 0. If I wanted to write it out. And on my calculator, the last one would come up with a 7. Why?
Because it's fraction.
it rounds it. If the last number, however many numbers your calculator can hold, it always rounds up. So I'll have students tell me, Mrs. Thompson, this isn't repeating because there's a bunch of 6s and then there's a 7 at the end. That's because your calculator rounds it. But it is 0.6 repeating, right? So this is my repeat. This is my repeat. Repeat. Oh, we missed -2. -2 should be where? I. Okay? And the reason I didn't ask you if any of these are rational is why? Are all of these rational? Which numbers on this page are rational? All. Why? Because we can write them as what? Every single one of these numbers we can write as a, what's the word that goes with rational?
Fraction.
Fraction. Every single one we can write as a fraction. And if you can write it as a fraction, it is rational. So repeat and terminating get there. Now, I know you have changed repeating or terminating decimals to rational numbers. It's all about place value. In that, when you think of a decimal, this is our ones place in front of it, right? Right behind that is the tenths, and then you have the hundredths. And so when we read that number, we don't want to read it as 0.4, but 4 hundredths, right? Or 4 tenths. You agree? 4 tenths, not 4 hundredths. 4 tenths, so we would write it as 4 over 10. One of the first questions in your homework is this simple. 4 tenths, right? We could simplify that. Both are divisible by 2 to be 2/5. I would take either answer, 4 tenths or 2/5. -1, we don't read it as 0.97, but -1 and 97, place value of the 7 is 100. So we put -1 and 97 hundredths. Not 0.27, but 0 and 27 hundredths. And again, if you can simplify, you can just leave it like that. And it says, are these terminating decimals rational? Could we write them as fractions?
Yes.
Yes. Why? We could write as a what? Write as a fraction. If you can write something as a fraction, it is rational. Okay? So that's as simple as some of your homework questions are. But then we get to these ugly ones, called the repeating. And these are going to be a little ugly, just like those number lines yesterday were a little ugly, but it's okay. It's a process, and the first time after you see it, and if you practice it a few more, and if you want to do the 4 that are in your assignment and you need more to practice, come in. I'll give you more to practice, right? So if you need more, sometimes some of you need to practice more than maybe the 4. Some of you, after 2 of them, you're like, yeah, I get this. I don't need to do it anymore, okay? So here's the process. We are going to be repeating. It says you don't have to have the last place value when you're changing to a fraction. Instead, we're going to use this equation. How you change a repeating decimal to a fraction. The first thing you're going to do, we are going to be asked to convert 0.48 to a fraction. The first thing I want you to do right behind this is right below our problem, we're going to always write 1x equals. So write that, 1x. We want to put that number down. It is 0. What? 48, 48, and maybe we do it 3 times, right? The 4 and the 8 are repeating, okay? Now the next one that we're going to do only has 1 digit out of the maybe 2 or 3 repeating, the next example. When you have one number that repeats, okay, write this up towards the top. One that repeats, you're going to multiply by 10 because we want to move the decimal over 1 place. If you have 2 numbers or 2 digits that repeat, we're going to multiply by 100 because we want to move it 2 places. And if you have 3 is the most that we're going to have. We do it in this next example going down. You can see the 2, 0, and 7 repeat. 3 that repeat, we're going to multiply by 1,000. Okay? So, we need to multiply this because 2 numbers repeated by 100. Do you agree that 100 times 1x equals 100x? 100 times 1x equals 100x. Okay? We are now going to multiply this 0.4848 times 100. That moves the decimal 2 places. Right here. It is going to give us this digit, this number now. 48.4848, right? Put that down right behind the top, right behind it. Okay? Some of you aren't writing. I can see you have your hand up and you don't have your pencil on your paper, so write. So 1x equals that. Now, next to the side of your problem, so when we do this, this is where we're going to do this work, this 100x minus x. It says now subtract. Take 100 minus 1x, we get 99. Take 48 and subtract those, you get 48. Look at how nice that is. If you've done it right, everything cancels. Okay? And we're left with just 48. Now, you have to divide by 99. Now, some people don't like this, but write this in, please. Do division on both sides by 99. I am going to take this answer, 48 over 99. I'd be happy if you got that for answer. What did they do to get this answer? They divided them both by 3. You have your calculator in front of you. If you would please take 16 and divide it by 33 and see if you get 0.48 repeating. Yeah? 16? So that's how you could check it. We're going to not have calculators when we do this. So we're going to go to this next part. So in your homework, one of the things I'll have you do is always put, oh, this is where my answer is going to be, right? This answer is going to be a fraction, right? The first thing we want to identify is what is our 1x. So right below the problem, we're going to do the work over here. This is going to be the subtraction part. But please write 1x equals. We don't want to put the line in our repeating. So it would look like what? 207, 207. I don't think we need to write any more 207, right? Write this down right below in the same spot on top, okay? Since I have 3 numbers, 3 digits that repeat, what did we say we should multiply when 3 repeat? 1,000. So when we're trying to decide, remember, you're going to use this up here to help you decide, okay? So if we are looking at that, we now want to write 1,000 x equals. If I take this times 1,000, when I multiply over here by 1,000, I am now going to move the decimal 1, 2, 3 places, and I get 207.207, right? 207. Dot, dot, dot. Right below it, I'm going to put this 1x. I'm going to put minus 1x. Here is the most really crucial, important part of this. You need to line up your decimal points. This is 0 point. I need to have 0.207. Do you see why it's really important you line up the decimal points? If I put it way over here and subtract it, I'm subtracting from the back, right? 7, 0, 2, 7 minus 7, 0 minus 0, 2 minus 2, 7 minus 0, 7, 0, 2, equals 1,000 minus 1, 999, I still have an x with it. I'm trying to get rid of the x. I'm going to divide by my coefficient, 999. And on this side. Now, if you leave this answer, if you tell me x equals 207 over 999, I'm going to give you full credit. But they simplify it. When you look at the answers in the back, they're going to simplify. Because of all those 9s, we think we should be able to divide it by 9, right? 999, if we divide it by 9, 111, right? 207, I don't know if I can divide that. So 207 divided by 9. If you remember your rules for divisibility, if you add these digits, 7, 0, and 2, you get them to be 9. If they're divisible by 3, or divisible by 9 than that number, 207 is. So 9 goes into 20.
2 times.
6 times, right? How many times?
2.
2 times, thank you, 18, right? We're going to subtract 20 minus 18 gives us 2. We get 9 goes into 27. 3. So check on your calculator, is 23 divided by 111? 207, 207, 207. Until maybe it puts a 1 for the last one or something like that, right? Okay? We got one more to try. What's different about this one than the last one? Look at this question. Do both the 2 and 3 repeat?
No, just
Just the last one. Just one digit repeats. So we're going to do this one a little different. We're still going to do it because one repeats, right? Only one repeating. We're going to multiply it by 10. So they go 10x and 1x, and you're subtracting. But look what happens here when we start subtracting from the back. We get these zeros. But then all of a sudden, when we wind up our decimal point, this 3 minus 2 is 0.1, and we get 2.1. And then you get this, and remember our definition of a fraction said it has to be integers. 2.1 isn't an integer. So how do I get that decimal moved over one place? My last step at the end is multiplying both numerator and denominator by 10 to get 21 over 90. Okay, so we're going to try that for this one. Here's where our answer is going to be. It's going to be a fraction. It's going to be kind of an ugly fraction, right? We're going to start with what is our x equal to? 1x equals 0.025. Should I go 2525 or just a bunch of 5s? Just 5s. So the second question in your homework, I had people putting the 2 and the 5, even though the only one with the line has a 5, right? They were writing them both because they thought it was just like the one before. So just be really careful. You got to watch for those, okay? So now, since only one repeats, we're going to multiply by 9. One repeats. It's either 10, 100, or 1,000. So you're going to start with 10x. If I multiply this times 10, that means I'm moving this decimal over one place, which means it's now equal to 0.2555. Agreed? Yes?
How many times should we put like the 5, like
Just a
problem?
few, 3 or 4 times,
Does it
just so that
matter?
you can show that it's going to cancel. If you want to put 7 of them, you can, but like I put 3 or 4, something like that. Okay? Good question. Minus 1x. What was our original? 0. What was the original?
25.
0, 2, 5, 5. So if you wanted a few more 5s up here, you could. We're subtracting them from the back, right? 5 minus 5 is 0, minus 5 is 0. Oh, now I have a problem. All right, not a problem. But 5 minus 2 is 3. 2 minus 0 is 2. I got to keep my decimal. Okay? Can't just ignore the decimals, even though I know some of you would like to. 10 minus 1 gives us, this is where you get the 9x. You don't want to start, do you understand that, with 9x. Does that make sense? You have to start with 10 minus 1 because or else you can't get this number. Does that make sense? Okay. Now, we are going to be dividing both sides by 9. And x equals 0.23 over 9. I can't have it. I can't have this decimal in my fraction. I need it to be not a decimal. How many places am I trying to move my decimal point? 2. I'm going to multiply numerator and denominator by 100. That gives me 23. This gives me 900. Check it on your calculator. 23, 900. 23 divided by 900. Punch it in. So when we do that, yours might show us 0.025555 and then a 6, right? Because it rounds at the end. And then it says, why are repeating decimals rational? Because we can write them how? We can write as a fraction. It all comes back to writing as a fraction, okay? Now, we have a few minutes before you leave here. I want you to turn back to your assignment way towards the back. Page, thank you, 37. Can you do number 1 right now? It doesn't have to look like what we just did. We read that as 9 and 31 what? Hundredths. Write the mixed number. Right? You don't have to do all that ugly work, right, that we just did. This is 9 and 31 hundredths. Eat that easy, right? The ones that I'm going to circle for you, they need the work that we just did. Number 2, number 3, number 5, and number 6. Those are the ones that need that work, like those last 2. So if we start, here's what I would suggest, that you leave a space right here for your answer, right? It's going to be a fraction. And right below it, I might write down, and for some of you, this gets really cramped. Like you write huge, like your numbers are like filling most of the page to do this. Take a sheet of notebook paper, second shelf back there, I got more notebook paper, and do your work on that and just put it in here. What does my x equal for this one? 0. What?
47.
575757, right? So multiplying by 10, 100, or 1,000. How many repeat?
100.
2 repeat 100. So back here is where I'm going to show my work. 100x equals 57.5757. So this is where you're asking how many 57s would I put? Just enough so I can kind of see. Okay? What are we subtracting from it? If I was going to ask you, we want to subtract what, Dylan? So right below the 100, I'm going to put minus what? 1x, nice. And over here?
0.5757.
Sure, nice. Okay? If I'm doing that, okay? Dustin, you ready? 100 minus 1 gives us? 99x. Back here, all these 5 7s, right, behind the decimal cancel. And I'm left with 57. And my last step, I'm doing my last step. What do I have to do, Andy? Divide by 99. Here's my answer, right? That's what I'm going to put over here. 57.99. 7 plus 5 is how much? 7 plus 5. How much? I had 7 and 5. I get 12. So could this be simplified? 7 plus 5, 12. 3 goes into that. But I'm okay if you leave it like this, but I just want you to know that the answer in the back, they simplify. They divide it both by 3. Okay? Yeah.
Or when we did the minus 1 equals 0.005757, why is it 0.00? Why do we add the 2 extra zeros?
You don't have to put those back in. But you have to show that these subtract off, right?
Yeah, but where do those come from? So that way we can get the step.
Oh, when you put 100x, you wrote it down wrong. Did you write 100x as, you're taking this number and you're moving the decimal over. You have to write it as 57. If you multiply one side of this equation, right?
Okay.
So you kept this as 0.57 and you kept the bottom one the same. This top one has to get bigger, right?
Okay.
Okay. And look back, the reason I said in your notes is this steps right here, this is gonna help you if you get stuck. The other thing, go to YouTube and put in, convert repeating decimal to a fraction. You'll see them do it like this and many, many, many other ways, okay? So,